The problem in this experiment is to determine if Newton's second law can provide an accurate prediction of velocity for an object with an unchanging direction. This information is interesting because it allows us to predict the future position of an object in motion. As you can see, the object, a toy truck, is moving in the negative x direction for about 0.5 seconds. The plots at each frame are displayed here. If we abstract the data points from two frames and employ the basic kinematic relationship that velocity is displacement over time, we yield the following result. The velocity vector is equal to 58.939 meters per second in the negative x direction. But why do we assume that the velocity is unchanging, or staying constant, throughout the entire time? This is due to Newton's second law. When we assume that forces are balanced in a system, then no acceleration is occurring. In other words, there is no change in velocity. This allows us to use the determined velocity to calculate and predict the position over a certain time. As shown here, we can use the initial position, the velocity, and the delta time to inform the final position. In computational modeling, this yields a linear change in position. Note that the graph has a negative slope because the truck moves in the negative x direction. When the experimental slope in blue is compared with the computational model in red, we see that Newton's second law can be fairly accurate in predicting the change in position of a system. The two graphs nearly fall on top of each other. Clearly, the graphs are different due to potential errors in real-world experimentation. It is difficult to acquire a true observed net force when, for example, the friction between the tires and the table can affect the change in velocity, or air resistance as well. If the axes were plotted differently and the truck was moving in the positive x direction, the only change that would occur is that the velocity would be moving upwards on the graph and the slope would be positive. But it wouldn't affect the magnitude of the velocity, simply just how we notate the direction.